Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we were solving the previous year questions of GATE Chemical Engineering, and we had already solved GATE 1990, and we were solving GATE 1991. We have completed the section A of 1991. So today onwards we will solve section B, and today we have the very first question on your screen. So without wasting time, we'll go to the question. So what question is saying? Nitrogen from a cylinder is bubbled through acetone at 1.1 bar and 323 Kelvin at a rate of 2 into 10 to the minus 4 meter cube per minute. So we have volumetric flow rate, okay, at 1.1 bar and 323 Kelvin. The nitrogen saturated with acetone vapor. Nitrogen saturated with acetone vapor. That means nitrogen is going through the acetone, and after the saturation point, the maximum amount of nitrogen that can dissolve in the acetone that will leave the cylinder leaves at 1.013 bar 308 Kelvin at a rate of 3.83 into 10 to the minus 4 meter cube per minute. What is the vapor pressure of acetone at 308 Kelvin? Okay. So very first, the acetone vapor is in the cylinder and the nitrogen is coming from the down. After nitrogen going to the acetone vapor, going through acetone vapor at the saturation point, the maximum limit of the nitrogen plus acetone will go out. Okay. So we have to find the vapor pressure of acetone at 308 Kelvin. Very first thing, both are gases. At condition 2, at condition 2, we only have nitrogen and acetone, right? So partial pressure of acid N2 and partial pressure of acetone will be the pressure. Okay. So partial pressure of N2 will act as the vapor pressure of N2 because it is at the saturation point, because nitrogen is at the saturation point. Up to that point, the nitrogen gas will not dissolve in the acetone. Okay, will not go through the acetone. So the vapor pressure will be equal to the partial pressure of acetone in this condition, right? So we have to find the vapor pressure of acetone. So vapor pressure denoted by Psat, okay, and acetone at 308 Kelvin in the question. Okay, so partial pressure of acetone at 308 Kelvin will be equal to the vapor pressure of acetone. So partial pressure is equal to the mole fraction of acetone into the total pressure at 308 Kelvin. That is 1.013 bar. We have already put the value. But we have to find the mole fraction of acetone. Okay. We have to calculate mole fraction of acetone. Then we will put the value in equation 1. Okay. We know that mole fraction of acetone is equal to moles of acetone divided by the total moles. Similarly, mole fraction of N2, moles of nitrogen divided by the total moles. And we know that moles of acetone, mole fraction of acetone plus mole fraction of nitrogen will be equal to 1 always. The summation of mole fractions is always equal to 1, right? Summation of all the component which is present in the one to n. Okay, this summation of mole fraction of all the component always is equal to 1, always. Okay, we know that, we know very well. Okay, so next step, at condition 1 we will find the moles. How? PV is equal to nRT. So the mole at condition 1 we only have we only have nitrogen gas. So at this point, when we will apply PV equal to nRT, it will give only the moles of nitrogen. So the moles of nitrogen coming 0.00819. Okay. At condition 2 we have mixture of N2 and acetone. So when we will find the moles, it will give the total moles, which is the total moles, that is summation of moles of nitrogen and moles of acetone, right? So the total moles will be 0.01515. Now, mole fraction of N2 will be moles of N2 divided by the total moles. Moles of N2 we just have calculated. This is at condition 1 and this is at condition 2, the total moles. The mole fraction is 0.54, right? Y of acetone plus Y of N2 equal to 1. We have just discussed in the previous slide. So Y of acetone will be 0.46. Partial vapor pressure of acetone is equal to the partial pressure of acetone is equal to mole fraction of acetone into total pressure, right? So we have calculated the mole fraction of acetone, that is 0.46, and at 308 the pressure is 1.013 bar. Okay, so answer is 0.467 bar. That is the vapor pressure equal to partial pressure of nitrogen, right? Sorry, acetone. Partial pressure equal to vapor pressure of acetone. We have to calculate the vapor pressure of acetone at 308 Kelvin. Okay, so this is the thing. If you have any doubt, just comment it below. Okay. Now the next question. What size of orifice would give a pressure difference of 41 centimeter water column for the flow of liquid styrene of specific gravity 0.9 at 0.005 meter cube per second in a 250 mm diameter pipe? Assume CD is equal to 0.62. Okay. So very first thing we have to understand this formula. We have to understand this formula. When water flows inside the pipe and the manometric fluid is mercury, then we use this formula, right? Similar thing is happening here. The flowing fluid is styrene, which is the gravity of specific gravity of 0.9. That means the density of 900. And the water act as mercury for styrene because it is heavier than styrene. So water is a manometric fluid here, and which is giving the pressure difference of 41 centimeter of water column. That means in case of water and mercury, X is mercury because it is manometric fluid, and H is reading of the water flowing through the pipe. But similarly, the styrene flowing in the pipe, that means it become H, and X will be the reading of water column. Okay, right? Hope you understand. Now we know that for calculating D naught we have formula. We have given with the flow rate. Flow rate is equal to Q is equal to A into velocity. That will remain constant throughout the pipe and as well as at the orifice. So flow rate at the orifice will be A naught V naught. Q is equal to, we have given, pi d square naught by 4. That is the area of the orifice, and V naught we have to find out. Ultimately we will get this value. Okay, ultimately we will get this value. Okay, 0.07 upon d naught square meters cube per second. We will not leave the unit for single second. Okay, so then we will put in equation 1. This is our equation 1. Okay, so we have put the value. X is 0.41. Water will act as a water is actually manometric fluid, but it is heavier than the styrene. So X will be 0.41, and density or specific gravity you can put here. You can write is like this as well. 0.41. Actually today I don't have my writing pad. Okay, so I'm just managing with my keypad, laptop keypad. 1 divided by 0.9 minus 1. Okay, you can write it as well like this. The same value will come. So you will get H is equal to 0.46 meter. Now putting all the values in first equation. So this is equal to, will result in this. Now putting all the numerical values. Okay, beta is d naught diameter of orifice, ratio of diameter of orifice to the diameter of pipe. In Venturi meter, beta is the ratio of diameter of throat to the diameter of the pipe, right? So we will get this value. Now squaring both sides, we will get this value. Okay. Now just mathematical things, calculating, we will get the d naught as 235 or 235 mm, 0.235 meter or 235 mm. So this is the final answer. So hope you understand these two questions. These are very easy, and just for building the concept. If you are novice in the field of chemical engineering and you are just you have just started the preparation, then these little concept will help you a lot. Okay. So bye guys, if you have any kind of problem, just comment it below. I'll reply as soon as possible. If possible, I will upload my notes as well. Okay. So bye guys, take care. Bye.